The goal of CS50x isn't just to teach programming, it's to help us develop computational thinking. That means learning how to solve problems like a computer does, logically, efficiently, and step by step. Let's start with something simple: counting. We usually count with our fingers, 1, 2, 3, all the way up to 10. Let's call it an array, or base 1. One finger equals one number. But computers, they use a different trick, binary or base 2. Instead of raising one finger per number, each finger represents a bit. Down means 0, up means 1. So with 5 fingers, we can represent numbers from 0 to 31. That's 2 to 31. Power of 5 combinations. This is the power of binary. Each finger doesn't just mean one more. It doubles the value of the previous one. We humans use base 10, also known as the decimal system. Take the number 123. It is equal to 1 times 10 to the power of 2, plus 2 times 10 to the power of 1, plus 3 times 10 to the power of 0, which equals 123. But in a binary, it's the same idea, just with 2 as the base. For example, the binary number 110. 1 times 2 to the power of 2, plus 1 times 2 to the power of 1, plus 0 times 2 to the power of 0. That equals 4 plus 2 plus 0, which is 6. Now imagine we store 8 bits. That's 1 byte. How many values can that represent? 2 to the power of 8 equals 256 possibilities, from 0 to 255. That's where ASCII comes in. ASCII assigns a number to each character. For example, the capital letter A is represented by the number 65. In binary, that's 01000001. That's how computers store text. It's all numbers behind the scenes. But what about all the world's languages, and even emojis? That's where Unicode comes in. It's a global standard. In one version called UTF-32, we use 32 bits to represent a single character. That means we're not limited to 256 characters anymore. We can now represent over 4 billion. Now let's talk about solving problems efficiently. Imagine a graph. The horizontal axis shows the size of the problem. The vertical axis shows the time it takes to solve it. Different algorithms behave differently. A linear algorithm is called big O of n. One that cuts the problem in half is big O of n divided by 2. A very fast one is big O of log of n. This is called big O notation. It helps us predict how our code will perform as problems grow larger. To apply what we learned, our first problem set was to build a Scratch project with some specific rules. Use at least 2 sprites, and not both cats. Include at least 3 scripts, use 1 conditional, 1 loop, and 1 variable. And create at least 1 custom block with 1 input. So, I built a game called Slicey. It's a fruit slicing game. Fruits fall from the top of the screen, and you slice them by hovering your mouse over them. Each time you slice a fruit, you get a point. Your score updates live and is shown at the end of the game. As the game continues, new fruit types are introduced to keep it exciting. It was fun and challenging. Importantly, it made me think like a programmer. So in just 1 week of CS50x, we've gone from counting with our fingers to understanding how computers store characters to analyzing how fast our code runs. It's not just about writing code, it's about thinking clearly and solving problems smartly. I'll keep sharing what I learn, week by week. Let's keep going.